The first requirement of reusable packaging is certainly its ability to clearly distinguish itself from conventional packaging of the same type. This allows consumers to always and immediately identify the type of purchase they are making, and therefore how the packaging must be handled once the product has been consumed. Immediately after that, other no less important requirements come into play. These include dimensional standardization, compatibility with a wide variety of industrial standards, and clear reference markings for proper item orientation throughout automated processes. The packaging must be designed to maximize the number of reusable elements and allow for fully automatic handling along the entire reverse and regeneration cycle. From a mechanical standpoint, it must ensure formal stability, calibrated weight, a controlled center of gravity, chemical inertia, and extreme durability in order to withstand multiple reuse cycles. Finally, reusable commercial packaging must also express value. It must allow easy separation of components, simple and effective cleaning and sanitization, high-quality recovery of materials, and straightforward regeneration of markings and identifiers. Reusable commercial packaging must be perfectly traceable throughout the entire reverse processing workflow. One of the most important reasons is that reusable packaging must be conveniently refilled with the same contained product for all reuse cycles. This allows significant savings, especially in terms of reducing aromatic contamination. High-density, high-turnover commercial products are marketed through large retail chains, and it is precisely here that the reverse process must begin. The reverse process begins with consumers returning used packaging. Dedicated reverse vending machines must therefore be installed, which consumers can conveniently find and use in the very same place where they can also purchase the new product. They will simply need to go to the shopping center for new purchases carrying a bag containing the used packaging, deposit it before entering, and then use the same bag for the newly purchased products. An efficient and practical RVM for reusable packaging must have at least the following characteristics. It must accept only enabled items, exclude all foreign objects, take up little floor space, store items properly, be robust and reliable, and require minimal maintenance. At the same time, it has to be easy and fast to use, convenient for the user, safe from accidents, capable of tracking the delivered packaging, and able to assign credits to the depositor. Pneumatic transport systems such as those patented by Heekit Packaging, which push used packaging upwards, prove to be perfectly suited to fully and effectively meet all these requirements. During the planning phase toward the implementation of a first pilot project, it is necessary to carry out certain calculations with due care. First of all, the production of new reusable packaging must be organized, and possibly their assembly if they consist of multiple parts, as in the case of the Heekit Packaging project. This operation can be carried out with limited equipment and semi-automatic lines, meaning not excessively pushed in terms of productivity, since the ex novo production of these packages is a sporadic event that only periodically affects the processing cycle. For the same reason, the distance between production and the system implementation area is of relatively marginal importance, just as in the case of preform production in traditional systems. More important, instead, is determining the quantity of these new packages, which, based on the rotation speed of the contained product, must take into account both active packaging ready for sale, those in the consumption phase, and those undergoing regeneration processing. The quantity of these packages can be calculated on a weekly or monthly basis depending on the product consumption speed, which, for example, can differ greatly between a soft drink, olive oil, or detergent. As for the decision regarding the territorial area in which to implement a first pilot project of this kind, distances are very important for overall economics and manageability, and the choice should certainly fall on an area where a pre-existing filling plant is present. A traditional filling plant generally consists of the following processing phases and related production stations: loading the preforms, orientation and rinsing of preforms, blowing and filling, capping, labeling and marking, bundling and palletizing, product shipping. The simplest and most immediate action is to develop a small reusable packaging regeneration line, complete with all processing steps, in parallel with the traditional one. In this way, at minimum, existing tanks can be used together with a range of already available structures. The elements that make up this type of production line are loading used packaging, orientation and separation of cap and or seal ring, washing and sanitizing, filling, capping and remarking, bundling and palletizing. Washing centers, as well as packaging orientation and separation stations, are overall relatively low-cost equipment with limited footprint, especially when considering small-scale production. This type of equipment and setup is by no means new, and there are highly specialized companies that have developed significant know-how over the years, mainly derived from glass bottle processing, a treatment that, from a strictly hygienic standpoint, is still essential today, but which in the past was also strongly oriented toward reuse, a practice that over time proved economically unfeasible due to issues related to the material, such as weight and fragility. However, precisely in an attempt to make this practice economically viable, interested companies invested heavily in the research of increasingly efficient and low-consumption systems, which today, with the use of PET and reuse concepts, can be relaunched with extremely attractive prospects. Hikit Packaging, by meticulously designing every aspect of its reuse system across all phases, from the return of used packaging to refilling, offers small and simple technical solutions that prove to be of fundamental and crucial importance. In particular, the slots in the neck of its reusable bottles allow, together with the stability and orientability of the packaging, the cutting of the cap's tamper-evident ring without in any way damaging the packaging, avoiding the risk of producing scrap and breakage, thus automatically and safely separating it from the bottle to allow for new capping. Although current European reuse regulations do not require the use of tethered caps, an evident paradox, considering the indispensable high-efficiency machinability always required by this type of packaging, this practical design proves extremely advantageous precisely in the case of tethered caps. In this way, the material can be entirely recovered and, through the reading of codes on the bottle, easily identified and separated by type and color, enabling the collection of very high-quality recyclable material at extremely low cost. Valuable materials such as PP or HDPE thus require minimal processing resources, transforming an operation that is in any case necessary, since the tamper-evident ring is always present, into a true economic asset capable of generating profit that compensates for and significantly reduces the overall costs of the entire processing cycle. In meticulously designing every aspect of its reuse system, Hikit Packaging has also focused on adapting existing washing and sanitization technologies to achieve maximum efficiency in line with these new regulatory orientations toward reuse, where PET is today universally considered the most suitable and promising material, confirming the insights that the Hikit Packaging team had already developed some time ago. The treatment phases of reusable packaging are typically the following: external washing, internal washing with the bottles turned upside down, internal and external drying, sanitization through EBM irradiation. One important, if not fundamental and essential, aspect is to provide for inverted bottle orientation. First of all, unlike glass, although PET has a density greater than 1 and therefore does not float, this ratio is extremely low, which would certainly cause practical handling issues and poor control of items during movement. Moreover, inverted orientation, together with shapes specifically designed for maximum washing efficiency, makes it possible to minimize water consumption and simultaneously ensure that containers are fully drained, details that are far from negligible in view of the future expansion of these reuse systems. After a first pilot implementation of a reusable commercial packaging regeneration line, the system can easily grow by adding multiple diversified product lines that can benefit from the same orientation, separation, washing, and sanitization facilities. Only an automated sorting and conveying system will be required, systems that already exist and are extremely fast and precise, to direct the packaging to the filling line of the product to which it is dedicated. This separation will occur simply through the tracking system coding, which, in the case of the Hikit Packaging project, can also involve the specific color of the bottle's cover label. The expansion of the reuse system can therefore take place gradually, with ample time to become familiar with this new practice, thus avoiding the risk of defects and other issues caused by the demands of aggressive productivity. As new reuse lines are optimized and grow, the old production lines can consequently be scaled down, while remaining active for as long as necessary to ensure full safety and manageability of the new lines. The maximum convenience and efficiency of a reusable packaging system at scale can be achieved when it is adopted by multiple consortium brands. At that point, filling plants may find themselves with a large amount of available space, which they can use to implement additional production lines, as well as simpler and less costly facilities, freed from the delicate processing phases involved in manufacturing a bottle from scratch. The basic concept, even more valid in the complex processing of PET, is that it is certainly much simpler and far less costly to wash a bottle, especially one that contains a beverage, than to create it from scratch each time. Beyond costs, the advantages in terms of environmental pollution, producer responsibility, quality, and all other aspects are simply not comparable. The fundamental standardization of packaging allows for complete interoperability in management and processing. However, it is erroneous to believe that this reduces the distinctive properties of each product or brand participating in such a system. In fact, excessive diversification in terms of shapes and colors ultimately results in a kind of post hoc homogenization that is disorderly and questionable. Conversely, precise and immutable references immediately convey, first and foremost, a high social value of the brand in terms of contextual ecological sustainability, followed by perceptual clarity that helps rather than confuses the consumer, as well as ease of comparison and genuine choice based on the real primary characteristics linked to product quality, while also offering packaging that is far more efficient, safe, and high performance. In the patented HeKit packaging bottle project, the color of the regenerable HDPE cover label and the customized graphics printed on it using high durability inks represent the essential and entirely sufficient distinctive elements to guide consumers, delivering packaging quality that is clearly and decisively superior to any single-use packaging. This is how a centralized and shared reusable packaging regeneration facility is configured: arrival of harvesting pallets, bulk unloading conveyor, loading parts, vertical piece orientation, separation cap seal, collector separate components for recycling, pre-selector grouping by type of content or color, regeneration washing, marking restoration, Z-axis reorientation, collection of disposed, worn out, or defective items for recycling, dynamic palletizing preconditioned packaging. In this case as well, calculating the distances within the service area is important. Typically and conveniently, these facilities should not be implemented at distances greater than 50 to 70 kilometers from the filling plant and should serve an area roughly equivalent to a province. The implications to be considered on a case-by-case basis are many and specific, but in anticipation of expansion on a national scale, it may be advantageous to fragment large existing filling plants and distribute them evenly region by region, province by province. These will require less space, which can be easily sourced, be faithfully replicated in series without incurring particular planning and design burdens, and become more controllable, with the possibility of compensating for one another if necessary. A fundamentally important aspect to avoid dangerous contamination is to keep the two main streams involving containers for food products and chemical products well separated from the source, already at the return phase. RVMs must have completely different intake openings, and the corresponding packaging must therefore feature incompatible shapes and dimensions, so as to categorically prevent the insertion of inappropriate packaging into the respective RVMs. To complete a high-quality and highly efficient reuse system, an extremely comprehensive and sophisticated control and management software is indispensable, capable of monitoring and managing the entire process at every stage, such as logistics, rotations, statistics, and more, as well as providing valuable real-time information on the market prices of consumable materials. Contact HeKit Packaging to receive more information.